Today we're going to look at exclusive and independent events. I'm going to start by explaining to you what exclusive events are. Exclusive events are events when we draw a diagram where there is no intersection. So events A and B on the board here do not meet, therefore we call them exclusive events or mutually exclusive events. What we must remember when we come to the terminology, mathematical terminology, is that probability of A intersecting B will equal to 0. Why is it equal to 0? Because A intersecting B is empty. So A intersecting B is an empty set. And you remember that this is the symbol for empty set. You've got an O and a cross coming across. So A intersecting B is an empty set, therefore the intersection is 0. And when this happens, these events are mutually exclusive. You would want an example where we have mutually exclusive events. In a school, if you are below 20 and you are between 35 and 40, those are mutually exclusive events. This is you are less than 20 here. If you are less than 20 and you are between 30 and 40, this is set B, that is set A. You cannot find anyone who can be in set A and be in set B at the same time. So if you are less than 20 years, you are in set A. If you are between 30 and 40, and there's no one who can be in both sets because your age is fixed. This is an example of mutually exclusive events. I move on to independent events. Who are the independent events? Independent events are two events that do not affect each other. I'm not going to use a set event diagram for them, but I'm going to give you an example first. Then we go to the rule that you are supposed to remember for IGCSE, or if you are writing ZIMSEC, that's what the rule is what you are supposed to remember. Independent events are events that do not affect each other. Their occurrence does not affect each other. So each event can happen irregardless of what happened with the other. A good example is a mother. If you are a mother and you have 7 girls already and you are pregnant with your 8th child, the probability that you get a boy is not dependent on the fact that you have 7 girls, or getting another girl for your number 8 child is not dependent on the 7 unless you are an abnormal mother. If you are a normal mother, every pregnancy has got a probability of boy a half and girl a half. Those are an example of independent events. What happened with your other 7 pregnancies does not affect the pregnancy that you have currently. Therefore, we call them independent events. And what you are supposed to check for independent events is a rule that we call the independent events rule. What does your independent events rule say? It says probability of A intersecting B is actually equal to probability of A times the probability of B. So if you find this is true for 2 events, then you know they are independent. The events can occur one event on its own and not affecting the occurrence of the next event. I'm going to move on and give you an example. I'm giving you 2 examples today. Example number 1, as you can see it on the board, it says a ball is selected at random from a bag containing 3 red balls, 4 black balls, and 5 green balls. The first ball is replaced and the second is selected. So we call this picking and replacing. You have got to get that part right, that we are replacing. There are times where we do not replace. This time we are replacing. You pick the ball, you put it back, and you continue with your experiment with your total of 3 red, 4 black, and 5 green balls. So now the question says, find the probability of obtaining 2 red balls. The first thing is for you to check, are these mutually exclusive? Are these independent events? This is a good example of your independent events. So the probability that you pick 2 red balls, picking a red ball first time does not affect the probability of picking the red ball the next time. So let us work out example 1, which our example 1, I'm doing number 1A. I figured out that they are independent, so I'm going to multiply them. I want 2 red balls. So the probability of 2 red will equal to, first I've got to multiply the probability. So it's probability of red times the probability of red, because I've realized that they are independent. So what is the probability of getting a red from our example? We have 3 red balls, and the total of balls that we have is actually 12. So this is equal to 3 out of 12 multiplied by, again, because we have returned the red ball after picking, we still have our 3 red and our total of 12. So multiply by 3 over 12. And the answer here, I would reduce this to their lowest terms, and I'm getting 1 out of 16. I'm going to move on to 2B. I want 2 green balls. They say find the probability of obtaining 2 green balls. My 2 green balls, again, I'm going to put the B part for you on the board. My 2 green balls, the probability of 2 green, again, I have got independent events, so it is probability of green multiplied by probability of green. Looking at my number of balls, I'm actually a 5 green out of the 12, so it is 5 over 12 multiplied by 5 over 12, and that gives me 25 over 144, and there's nothing common, so I leave it there. I'm going to move on to do question number 5 for you, which is my next example. Our next example, as you can see it on the board, reads, when a golfer plays any hole, he will take 3, 4, 5, 6, or 7 strokes with probability 1 over 10, 1 over 5, 2 over 5, and 1 over 5, and for 7 you've got 1 over 10 respectively. I hope you get the word respectively. It simply means that each probability is matched to the number of strokes accordingly. So if you are looking at 7 strokes, the probability of 7 strokes is 1 over 10. So now let us answer quickly the questions we have. Find the probability of the following events, scoring 4 on each of the first 3 holes. So we want a 4 on each of the first 3 holes, which is simple. So we want probability of a 4, and a 4. And this is another example of events that are independent, and they have got to multiply each other if they're independent using the rule. So it's probability of a 4 multiplied by probability of a 4 multiplied by a probability of a 4. And what does that give us? Probability of 4, when you look at it, 4 is coming second, so its probability is 1 over 5. So this is 1 over 5 multiplied by 1 over 5. multiplied by 1 over 5, which gives us 1 over 125. And it's already in its lowest steps. Going to B. B says scoring 3, 4, and 5. In that order. If they had not said in that order, we would have to look at different arrangements. But this time they told us in that order. So we want probability of 3, 4, and our 5. So this gives us probability of 3, 4, and 5 will give us probability of 3, because they're independent, probability of 4 multiplied by probability of 5. And we go to 3. 3 is matched with 1 over 10. 4 is matched with 1 over 5. And our probability for 5 is matched with 2 over 5. So multiplying the 2, that's common. Because I'm multiplying, I can cross multiply and get a 1 and a 5. Again, my answer is 1 over 25. I will move on to C quickly. For our example 2C, oh, by the way, we are doing example 2. For our example 2C, we have got scoring a total of 28 for the first 4 holes. Here you need to think a bit. You now need a total of 28, and you must check which 4 can give you 28. If you add 3 plus 4 plus 5 plus 6, you won't get 28. Looking at those numbers, the only 4 that can give you 28 is a 7, 7, 7, 7. That's the one that can give you 28. So we are looking at probability of 7, 7, 7, and another 7. And this is equal to probability of 1, 7, another 7, another 7, and another 7. So probability of 7, we are told, is 1 over 10. So this is 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10. And that gives us 1 over how many? 10,000, 4 zeros. So that is the probability of getting a total of 28. This is a total of 28. I'm going to move on to D, scoring a total of 10 for the first 3 holes. So first 3 holes, a total of 10. This one, we have got to check again who can give us a total of 10 with only 3. I can see a combination of 3, 3, and 4. Those are the only ones that can give us a total of 10. So we are saying probability of 3, 3, and a 4. This will give us a total of 10. But you will see there's a trick. These can come as 4, 3, 3. They can come as 3, 4, 3. There are different arrangements, and we are going to add all these probabilities have to be added up for us to get that. Or we will find they will be the same probabilities. This can give us the same. So we can just multiply by 3. This will be probability of 3 multiplied by probability of 3 multiplied by probability of 4. And starting with the order here is mattering, but because we are multiplying, it's just the same as taking each one of these and multiplying it by 3. So this is equal to probability of a 3 is written as 1 over 10. If you want another 3, 1 over 10. And for you to get a 4, it is 1 over 5. So this is the probability of one of these. So there are 3 of them multiplied by 3. So we are getting here 3 over 10 times 10 over 500. This is the probability of getting a total of 10, which we can do in 3 different ways. And the very last one is scoring a total of 20. We want to score a total of 20. If we are to score a total of 20, for the first 3 holes, we are not worried about anything that comes after the first 3 holes. We are scoring a total of 20. And when I look at it, which ones can give us a total of 20? We have got 3, so we are looking at 6. If you take your 6 and your 4, you get 10. You take your 7, you do not get 20. We are looking for the ones that can add up to 20. The ones that will add up to 20 for us for the first 3 are actually your 7, 7, and your 6, because 7, 7, and 6 will add up to 14 plus 6. So you have to look through and make sure you have picked all those that can give you a total of 20. So 7, 7, and your 6 will give you a total of 20. Please make sure you are accurate. So this is equal to probability of 7 multiplied by probability of 7. Now when you multiply this, remember the order can change. I can have 6, 7, 7. I can have 7, 6, 7. This is another case of multiplying by 3 because they can come in different arrangements. So this is probability of a 7 is 1 over 10. And probability of a 6, as you can see, is 1 over 5. And this can happen in 3 ways. So this is equal to 3 over 500 again. And this is in its lowest form. So I'll meet you again when we move to the next topic, which is using tree diagrams.